Okay, so this is the question in the last homework, and that's when you had 5 genes. And again, this question is really simple, very easy to solve. So let's do this together. So first, let's find our parental group. So I have this, right? And then I have here, this, and this. So now, okay, so first of all, I found my parental group. Now let me find my double crossover. So I have this. There's my other one. Okay, so double crossover again, also with parental groups are like the same. So if you have 4 parental groups, you have 4 double crossovers. If you have 2 parental groups, you have 2 double crossover. In the case of double crossover, you can sometimes, as I said, you have 4 parental groups. You might in real life, not in like these questions, but maybe in these questions. For example, I have 4 parental, and then I find out that I only have 3 double crossovers. What does that mean? It just means that it was that rare. The crossing over was that rare. It's not that it doesn't happen, it's just you didn't observe it in the lab. So don't freak out when that happens. Anyways, leaving that aside. So I have 4 parental groups, right? So again, I say I have 4 parental groups. What does that mean? It means it's 2 to the power 2, right? So that means I have 2 chromosomes. Okay, so I have 2 chromosomes, and I know I have A, B, C, and E. Okay, what are the different combos that I can have? So this is chromosome 1, chromosome 2. What I can have is I can have A, B, C, D, 4 genes here, and then the 5th gene here. So I can have 4 and 1 possibilities. I can have 3 genes on one chromosome and 2 genes on the other one. That is it. So if I have 2 genes here, I'll have 3, so it's the same way. Doesn't matter. If I have 1 here, I have 4, so it's like, what's the difference? So I can either have 4 and 1, 3 and 2, right? I can have 4 genes together, 1 here. I can have 3 genes together and 2 on the other side. Okay, perfect. I know that. So let me now put my parental groups together, right? So if I was to write my parental groups, as I can see here, I have 4 genes. Oh, I want it with 1, 3, and 2, meaning if I have A, C, B, E on one gene, right? The one equivalent to it, the other side would be D. And then if I had AC, this one, the one equivalent to it would be D, B, and E, right? Right, so it would have been this way somehow. Right, so here's my 5 genes, my 5 genes, my 5 genes, my 5 genes. But ignore the wild type ones. Oops. So anyways, what was I saying? So what do I notice? I notice the following. I notice that A and C stuck together, right? I notice that B and E also are stuck together. So A and C, B and E were together, D is on the other side, A and C here. When D was on the other side, B and E were still together. So what I realize is A and C always travel together, and B and E always travel together, and D travels on its own. Okay? When I look at my double crossover on the other hand, so this is for parental group, when I look at my double crossover, what I can see is I have C, okay, and would be the other equivalent for it? A, D, B, E. So here's my 5 total genes. Then I have A, D, then C, B, E. So those are my total 5 genes. 1, 2, 3, 4, 5. Here, 1, 2, 3, 4, 5. Anyways, what I notice is the following. BE still sticks together. BE still sticks together. Remember how I said A and C together, A and C together? Here, C and A separated, C and A separated. What does that mean? There was a crossover between A and C. So now I know that A and C are on one chromosome, right? They can either have BE together with them, or they can have D together with them. So now I just demonstrated that A and C had that cross. I just need to figure out on this chromosome, do I have D with them or do I have BE with them? Okay, so when I assumed, now I'm looking at the parental, right? When I assumed that D was on its own and B and E is with them, look what happens. So let me delete D. How many parental groups do I have? I have one parental group. When I delete D, this is wild type. Second, third parental group, fourth. So deleting D still gave me 2 chromosomes. That's not what I want, right? I want to end up with 2 parental groups, hence 1 chromosome. So now let me delete BE. When I delete BE, oh my god, what happens? So D and D, that's 1 parental group. AC and AC, that's another parental group. So that makes me realize the following, that BE is on its own chromosome, AC and D is on its own chromosome. Yay, I figured out where I know my yay seems very monotone, but anyways, I figured out where BE is and where my ACD are. So I figured out what's on my 2 separate chromosomes. Okay, so I figured out which gene go on which chromosome. Perfect. Now let me figure out the order. In order to figure out the order, first I need to figure out which ones are in cis and which ones are in trans. Okay, so AC are in cis of each other and D is on in trans. So I know that A and C are together and I know D is the one on the bottom. Now to figure out, so I use the parental group to figure out my cis and trans, remember the steps? And now I'm gonna use my double crossover to figure out the order. So I'll put C in the middle at one time, I'll put A in the middle, I'll put D in the middle once, right? And I know that A is in cis with C, D is the one that's far, C is in trans, cis with A, D is the one that's in trans, and then A and C are in trans to D, right? Okay, so now let's perform our double crossover. So here A comes down to wild type, goes back to A. D goes up to C, comes down to wild type, so C and D. Okay, let's do this for C. C goes down here, goes up here, so C is on its own. This is the plus sign, who cares? A, and then I come down to D, A and D. Wild type, wild type, wild type. Oh, so I have all these, and then I have A, D, C, A, D, C. Okay, now when I want to look at my double crossover, I forgot to delete my BE. So I have C and I have AD. Which one has my C and AD? This one. So now I know my order. So let me write the correct order for this one. It's C, A, and D. Right? C, A, D. I figured it out. I am happy now. Now let's figure out the mapping. Right? So let me erase all this. Let me erase my BE for each one of them. Here my BE is gone. My BE is gone. Let me erase this whole chunk so I have more space to write. So figured out my 2 chromosomes. Figured out my double crossovers. I will have C and I will have AD, right? So here are my 2 C's. 2 plus 1 is 3. Here are my 2 ADs, right? 1 plus 3 is 4. So here is my double crossover. Okay. So now, now let me delete my BE from everywhere else. BE. So if I delete this BE, I'll have wild type. Okay. A and A. CAD. Here, let me delete my BE. And here, let me delete my BE. Okay. So here's my wild type. Okay, so for wild type, I have 13 plus 17, which is 30. What's gonna be opposite to my wild type is gonna be my CAD, CAD, right? Here's where I see 3 of my genes. Then, so it's 15 plus 18, which is 32. Okay, so this is for one single crossover. So let me just cross them out so I don't get confused. Let me cross this out so I don't get confused. Right? My other single crossover. So the exam I'll just, don't have to rewrite them, but then I'm rewriting them here for you so it looks clear and you can follow up with me. Okay, and then I have my A's, right? So 23 plus 22 is 50. Here's my A. So on the other side, I'll have CD, obviously. 25 plus 23 is 48. Right? So that's how we got our numbers. Oh, sorry, this is 45. This is not 50. Anyways, so this is how we got our numbers, and we're happy with that. And now to find the map distances, right? So I would use our favorite equation. Let me write it out. Relative frequency is equal to single crossover plus double crossover over total times 100. Okay, so I figured out my I wrote down my equation and now I can find the answer. And then, as I said, C is gonna be C A D, right? That's how the order goes. Put positive for this one. So if I want the distance between A and C, when C crosses once, it's gonna be CD. So which one has my CD? So this one will give me the distance between C and A. Okay, and then when I have D is the one that's crossing over, I'll have CAD. Where do I have my CAD here? I have my CAD, and the other one would be wild type. So this will give me the distance between A and D. Okay, so I figured out which one would give me the distance between what. It's very tricky to erase on this thing. Anyways, so now I'm gonna apply this in the equation. If I want the distance between C and A, I'm gonna use 45 plus 48, right? Plus my double crossover, which is 3 plus 7, the whole thing over, yeah, they gave me the total, which is 1,000 times 100. Okay, so across these, this will give me 10. This will give me, did I make a mistake by any chance? I hope that I didn't. Oh, yes, I did make a mistake. It's plus 4. So this will give me 7, 90, 100, and what am I thinking? Yeah, 93, 100. So this will give me 10. Okay, so this is 10 MU, and then relative frequency, second relative frequency, that will give me this between A and D. I'll use this one. So it's 30 plus 32 plus my double crossover is 3 plus 4 over 1,000 times 100. This goes with this. 7 and 30. Hope I did the math correctly. 62 plus 7 is 69. Why do I have a feeling I did something wrong? I remember it being 7 in the homework. Anyways, so I get 6.9, which is equal to 7. I'm guessing I added one of the numbers incorrectly, but you're supposed to get 7 in map units. Take your time solving this. Don't get any numbers wrong, but at the same time try to practice and do it faster. And that's how you find your map units, and which is in cis and trans. And it was very easy. There were no tricks, right? You just need to minimize the number of parental groups. So we figure out which ones are on the same chromosomes and all that. Hope this helps, and thank you for watching.